Welcome everybody. In this tutorial I'll talk about the creation of customized hatch patterns. I've prepared a little example of this brick structure, which is the standardized brick used in Austria. And first of all, I'll show you where you can find the file for the hatch patterns because it's a little tricky to find. What you want to do is go to the root directory of your AutoCAD where you've installed it, and there you'll find the folder user data cache, which is a hidden folder, so you want to make sure to enable the viewing of hidden folders. And if you go in there, you'll find if you're using the English version, you'll find the folder called ENUS. If you're using the German version, you'll find the one called DED. So since I have both versions installed, I have both folders, and whichever one you choose or whichever one you find, there again you'll find support and template. So what you want to do is go into the support folder, and there you have all the files for the line types and the font types, and also the hatch patterns, which is the one we want to concern ourselves with. So the ones for the hatch patterns are those with the ending PAT. There's two of them. There's AutoCAD, which is for the US unit system, and there's also the AutoCAD ISO-PAT, which is for the metric system. So since I'm in Austria, we have the metric system, I'll be working with this one, but you use the one that's relevant for your work. If you open the file, what you'll find first of all is a very long list of numbers, and these are all the different pre-installed hatch patterns. So you see here the hatch pattern solid. There's also a description. Here it's in German, but basically it says area filling. And what you want to do is go down all the way to the bottom, and there's a little paragraph. Again, it's in German, but basically it says that user created hatches should be inserted after this paragraph. So you don't want to change anything up here. Up until here you want to leave it as it is, and you just, when you add new hatch patterns, you'll start from here. I've created a few of those already. And what you want to make sure also is that you always insert a blank line at the end. If you don't insert the blank line, then the hatch patterns you created won't work. So I'll switch back to AutoCAD, and here I copied the instructions from the AutoCAD help file. There's also more information in there if you need any further input. So basically, what the hatch pattern consists of are a couple of numbers separated by columns. So the first value is the angle, in which direction you're drawing the line. So value of 0 is horizontal lines and 90 is vertical lines, of course. Then with the next two parameters you specify the origin from where AutoCAD should calculate the hatch pattern. Then delta x is a sort of offset. So if I started with this line here, then delta x basically tells it that it should, as it moves on, it should be shifted by a certain value. And the delta y value is the distance between the lines. So if, for example, it's the distance between this line and this line. And then there's more values, dash 1, 2, and so on. What you can do with these is create lines that have blanks in them. So the value 1 would be this long drawn line, value 2 is the blank, then there's again the long drawn line. So you don't need a dash value for each segment, of course, only if you want a change in segments. Now I'll describe these parameters in more detail. Prepared a little colored hatch pattern so it's more obvious which value goes where. So the first one we want to talk about is the angle. As you can see, for the red and the yellow lines, they're horizontal, so the angle is set at 0. It's the same with both of them. Then the second value, the x-origin, is the offset I talked about before. So basically what it does is it starts off at a certain point which you define at the origin, and when you enter a delta x value, then it shifts every line, or it offsets every line by this value. So in this case it's 13, so that's this distance, and because the hatch pattern is multiplied infinitely, the next line again looks basically the same as this one, but it's actually moved another 13 to the right, so it starts off again at the same point. And the delta y value is simply the distance between the single lines. And then again, you have the dash values. In this case, for the red line, the first dash is this segment here, which is 25 centimeters long. Then there's a blank space of 1 centimeter. So we use two dash values. Basically the yellow lines have the same values, only the origin is different in the y-axis because it shouldn't start off down here, but up here. That's the distance between these two. And for the green and cyan lines, we have an angle of 90 degrees because they should be vertical. Again, the green line starts at 0, 0, whereas the cyan line starts at 25, 0. And again, the dash values are the lines that should be drawn and the blanks in between them. So this line has a dash value of 6.5, whereas the blank line has a dash value of minus 8.9, because if you want to insert a dash, you have to use negative values, then the line isn't drawn. And of course, there are different ways one could go about this specific pattern, but I chose to use 4 lines in the hatch file. So it's one line for the red part, another one for the yellow, for the green, and for the cyan. Now I'll go back to the hatch file, and I'll show you how these values are arrayed and how they work. So it's this, the hash pattern is called NFUG, and the first line, which was the red one in AutoCAD, starts off at, has an angle of 0 degrees because it's horizontal, starts off at the origin of 0, 0, which in this example would be right here, and then it has an x and delta x value of 13, which is the distance between this starting point and this one, and it has the 7.7 in delta y, which is this distance. And then there's the dash values, 25 for the line and minus 1 for the blank in between lines. The way that looks is basically just these red lines. That's what this line does. It draws, so to speak, the bottom lines of the bricks. Then the second line in the hatch file is the yellow one here. So it starts off again with a value of 0 degrees, because it's horizontal. And it starts off at the origin of 0 in x direction and 6.5 in the y direction, which would be this point in x and this value in y. And the 6.5 is the brick dimension. But the other values stay completely the same. It has again an offset of 13 centimeters, which is again this distance, and 7.7 centimeters, which is again the distance between the lines. And there's again the dash values for 25 for the drawn line, and -1 for the gap in between lines. So what this line does is the top lines of the bricks, as you can see. The third line, which is the green one, is the first vertical line. It's the left end of the brick. So it starts off again at the origin 0, 0. Has an angle of 90 degrees, of course. Origin 0, 0. And now the offset direction switches. So basically the offset in delta x is now 7.7. What it does is with each alternating line, with each line, it moves this piece up by 7.7 centimeters. And the delta y value is now the 13 we've used as an delta x value in the previous line, which is exactly this distance in between the two hatch lines. And then there's of course the values again for the lines and the gaps. So this value, the 6.5, again draws a line with the length of 6.5, and then there's a gap of the 8.9, and again 6.5, and so on. And the final line, which is the cyan one, but first I'll show you the green line again. So that's always this, the left ending of the brick, and it has the distance of 13 and the alternation of 7.7. And the final line, which is the cyan one, is the second ending of the brick. So it has a value for the angle of 90 degrees, of course, an origin of 25, 0, because it's now this line. It should start here. It should start right here. And then the offset values are the same again. Delta x is 7.7 again, because it should alternate the lines. So this one is here, the next one is 7.7 moved up along the axis, and the delta y value is again the 13, which is the value between this line and this line. You can see it here, it's dimensioned here, it's this distance. And again there's the dash values, 6.5 to draw the line, and 8.9 for the gap, and it starts off again with the 6.5. So that's what this line looks like. Sorry, it's this one. So you see it's this ending of the brick. And you probably noticed there's not much hustle about the creation of the hatch patterns, because you only have a limited number of values given how many different dashes you need. The most difficult part actually is if you have a certain pattern you want to achieve, you really have to draw it out and think about how you want to address the lines. because the way I did it was I used the offset command because I think it's a good thing to have. You could also use more hatch lines in the hatch file and do each one separately. You could say, yeah, there's one hatch line for this, one for that, and so on. But really use these offset values because, as you see, I now have 4 lines, and of course it's a little neater than to have, I don't know, 6 lines or even more. So you really have to put some thought into it, in which way these values, the delta x and the delta y, affect the pattern. And that's probably the difficult part about it. So it's really easy to just make a little sketch or draw it as I did it. I drew it into AutoCAD and added dimensions. And once you've got that figured out, how you want to address the different lines you want to create, then it's really simple to just enter the values. Okay, thanks for watching, guys. I hope it was clear enough to follow. And if you have any suggestions or recommendations, please let me know. Thanks.